This is Science Friday. I'm Ira Flato. Let's take a trip, shall we? We're plunging into the Pimlico Sound, a large lagoon off the coast of North Carolina. We're not here to look at fish or plant life. We're here to check out a shipwreck, specifically to learn about the microbes that live on and around this wreck. You see, just like you and I have our own microbiomes, which are different for everyone, shipwrecks have microbiomes too. And scientists study them to better understand what's living on these sunken ships and how to preserve them for future generations. We're looking for a shipwreck known locally as the Pappy's Lane Wreck. There it is. There it is, along with our guest, Dr. Erin Field, Assistant Professor of Biology at East Carolina University in Greenville, North Carolina, who is here to tell us all about the marvelous microbes that live on our shipwrecks. Welcome to Science Friday.
Thanks for having me.
Nice to have you. And just a note, this segment is being recorded with a live Zoom audience. Science Friday listeners can ask their own questions about shipwreck microbes. Learn more about joining a future live recording at sciencefriday.com/livestream. Hope you enjoyed our radio theater swim, Dr. Field.
Yeah, I'm really excited. Excited to talk about the shipwreck microbes and hear everyone's questions.
So you've swum out to this shipwreck before, I imagine.
I have, yes. It's a wonderful wreck in North Carolina, as you mentioned, the Pamlico Sound. And so the ship itself is about 50 meters long. It's steel hulled, so it's basically made of steel and iron. And it was originally thought to be a World War II warboat built in the 1940s. It then transitioned to a life as a barge, and it ran aground in the 60s, and it was abandoned there. So now it is just this staple in the community in Rodanthe.
And it's not in very deep water, as you can sort of wade out to it, can't you?
Correct. So it's a shallow water shipwreck, so you can wade out to it. If you go out there, you will find people kayaking around there. You'll find fish. You'll find snorkelers. It's a good location to go.
Let's talk about the microbiome that's on the ship. How do you actually collect microbial samples from a ship?
Yeah, so what we did was we went out to the ship itself and we were able to collect a few different sample types. So first, there are what we call shipwreck debris pieces. So these are pieces of the wreck that have already deteriorated and fallen off the intact part. And so we can collect those, and then we can scrape off the surface gently and collect the microbes that are on that. We were also able to drill pieces from the ship hull itself, both where it's submerged in water but not buried. And we also were able to collect drilled shipwreck pieces below the sediment line where they had just dredged. So we have a few different pieces that we collected, as well as sediment samples in the area around the wreck and the water as well.
Are the microbes different wherever you drill or scrape? Are they different kinds of microbes, or are they all the same?
Yeah, so that was one of the questions we really wanted to answer when we were looking at this wreck. So when you think about each shipwreck, everyone is unique. Everyone has its own story. It went down at different times. It was built in different places. It's in its own environment now. But even within one shipwreck site, we can see that there are differences. So the microbiome would be one example. So the microbes in the sediment nearby versus the water nearby versus the shipwreck itself were all different. And really cool was, if you look at the shipwreck itself, there were different microbes in different places on the wreck. So much like you think about your own microbiome, you have microbes everywhere, but the ones in your gut are different than the ones on your skin. The same thing happens on these shipwrecks.
Interesting. So what do you hope to do with this better understanding of what microbes are on the shipwrecks?
Yeah, so shipwrecks are fascinating, and the microbes can both be helpful and hurt the shipwreck environment. So when we look at microbes associated with these wrecks, some can contribute to what we call biocorrosion. So they will help deteriorate. So organisms such as iron oxidizing bacteria or bacteria that eat iron and make rust, that can actually cause deterioration of these wrecks. And we're trying to preserve these historical artifacts. So we want them to be maintained and preserved. So we want to control the growth of microbes that could cause damage. So we would like better early detection methods to know if they're there so that we can better design our mitigation methods for preservation. But we also want to maybe promote the growth of bacteria that can help preserve these wrecks. So there's also microbes that will make a biofilm, they'll attach and make this kind of protective layer that helps protect the wreck from corrosion by the ocean itself.
What could preservation technique look like? I mean, how do you preserve a ship sitting there in shallow water?
Yeah, that's a great question. And that's something we're really still working on. I mean, we haven't thought too much about how microbes really contribute to the deterioration. We have not been able to look at that enough. So I work with maritime archaeologists that are really excited about learning how they play this role so that we can design management strategies. Because like you said, it's a huge ship at the bottom of the ocean. So how do we protect it? And so that's something we're working on. Right now, there's a lot of methods that utilize things like um, other chemicals or ways to preserve and stop oxygen from attacking the wreck. And microbes can do something similar. So we will need to design methods that will be specific to the microbes.
We are on Zoom, live Zoom audio, and we have a question from Ken from Bloomfield Hills, Michigan. Go ahead, Ken.
Well, good morning. I was curious as to what depths will you find microbes on shipwrecks?
Good
Yeah,
question.
yeah, it's a great question, Ken. Um, when we think, if we look at water depth, there are microbes just about everywhere. So when a ship goes down, whether it's shallow water like we're looking at in Rodanthe, or it's really deep, say in the Gulf of Mexico or somewhere else, there will be microbes there. They are found in the water, they're in the sediment, and when that ship goes down, it becomes a new source of space, a place to live. All these microbes are competing for space and nutrients, so they've just found a new place that they could live. And then they will attach and start building their own community.
Is this a new concept about collecting a ship's microbiome? Because I don't remember hearing about this many years ago. Does this mean the location of a wreck impacts what microbes are on it? I mean, just learning all about this seems kind of new.
Yeah, it is new. So the maritime archaeologists here at East Carolina University have been studying wrecks for many, many years. And they know that microbes can contribute to some of these processes, but it's never really been evaluated. It's difficult to sample. So often these wrecks are very deep, so it can be difficult to get samples in order to look at microbes. But yeah, it's a new area that we're really trying to expand into.
When we say microbes, or you say microbes,
Mm-hmm.
does it mean a lot of different kinds of microbes? I mean, bacteria, viruses. What makes up a microbiome?
Yeah, that's great. Yes, is the short answer to that. And so we have bacteria, we'll have archaea, we'll have viruses. Basically, when we say microbe, I teach my students the simplest term really is anything you can't see by the naked eye. So all those organisms that you can't see without a microscope.
And so these microbes are coming in contact with other aquatic life that lives in the ocean there, right?
Yeah, they absolutely are. And so one of the things I think is so fascinating about shipwreck microbes is, a ship will go down and the microbes will be the first to attach most likely. They have a new home that they can take advantage of. They start building a community, contributing to carbon cycling and nitrogen cycling and aiding the entire biological community in the ocean. And then as they do that, this becomes an artificial reef. And so now other organisms can come in. We have the fish and turtles and corals and oysters that all come in and make a community. So these wrecks don't just have a historical relevance, but really they also have a really important ecological role.
Interesting. Let's go to Zoom again for a question from listener Abby about different kinds of wrecks. Go ahead, Abby.
Hi, Dr. Field. Have you noticed any differences in microbiomes of wrecks that are easily accessible by people versus those that are not? And if so, what do people introduce to the microbiome of a shipwreck?
Great question.
Yeah, that is a great question. We haven't had the opportunity to compare the microbes associated with one wreck versus another yet. That's something we really want to do more of because it is such a newer, younger field. But I would absolutely expect that the microbes will be different if the microbes on one shipwreck are different in different places. I would expect that microbes between different wrecks or different depths would absolutely be different. So we have microbes that live everywhere, but it doesn't mean that the same microbes live everywhere. And so that's really important thing to keep in mind.
Do you think that you are leaving a little bit of your microbiome behind when you go to that shipwreck?
Yeah, that's a great question. So we really work hard to wear gloves and protect. It's interesting because we're protecting the wreck from us because we have microbiome and we don't want it to affect our samples. But absolutely, I mean, if you go to a shipwreck and you're scuba diving and you're exploring or you're snorkeling and you touch it and you do things, absolutely, you can introduce a new microbiome to that wreck. And it's something that, we haven't had a chance to look at, but absolutely.
You know, studying the microbes on a shipwreck is not something you see in a catalog of a university when you go to apply to to go to school there. What got you interested in studying shipwrecks?
Well, the first thing is shipwrecks are just so cool. If you have the opportunity, you can't, say no. For me personally, being in North Carolina, we have thousands of shipwrecks across the coast. And so you have that connection to it already. And I have been studying iron oxidizing bacteria for many years now. And these are microbes that live on steel and iron-based sources. So I thought, why wouldn't they be on a steel-hulled shipwreck in the ocean? These organisms live in the ocean as well. So that was one of the things that got me really excited about it. And then I had the opportunity to work with Nathan Richards here at ECU in the Maritime Archaeology program. And he was also very excited to learn about how microbes may be contributing to biocorrosion or deterioration of these wrecks. So we teamed up and got started.
We have a question from your neighborhood. Listener Terry from North Carolina's Outer Banks is waiting with a question. Hi, go ahead, Terry.
Hi, thanks for taking my question. Hi, Erin. I'm a good friend of Nathan's, and my office is
Great.
at the Coastal Studies Institute, by the way. My question is about the salinity, because I know the Pamlico the salinity is variable, and I was wondering if that salinity played a big role in the difference in the microbiomes from the wreck to the sediments to the water.
That's an excellent question. And absolutely, salinity plays a very large role. It does for microbes in general. Microbes usually have a range that they can live in when it comes to salinity. And you're right, this one fluctuates in the Pamlico Sound. And so I would expect that it would affect which microbes are there. We find a mix of microbes that you could find typically in estuaries, but that can adapt and withstand salinity ranges that do fluctuate. I would also, back to the question that was asked earlier, when you think about the deep maybe wrecks versus here, salinity would play a role too. So if salinity and oxygen and other things are fluctuating in this estuary, it will affect which microbes are there and how they function compared to a deep wreck that maybe some of those conditions are more constant.
Yeah, let's talk about a deep wreck for a second, because I guess if a wreck goes deep enough down into the water, you get into an anaerobic, a lack of oxygen, right? You must find anaerobic bacteria or totally different kinds of bacteria living on those wrecks, I would imagine.
Yeah, absolutely. So if we have a more anoxic environment, then we will have the microbes that can grow without oxygen. We also can find that you can have these what we call micro niches. So we can have microbes that are living together where maybe we don't measure the oxygen, but somebody is able to produce a little bit that the others can use. But in general, the anaerobic bacteria would be expected in maybe some of those deeper sites, particularly in the sediment. So I mentioned that we were drilling the ship where we had just dredged. And so the sediment often, everything going on in there, the chemistry, the microbes, they use up all the oxygen. And so now we have more anaerobic processes and anaerobic microbes. So we had expected to see that too. And we did find them there.
I'm Ira Flato. This is Science Friday from WNYC Studios. We're talking with Erin Field, Assistant Professor of Biology at East Carolina University in Greenville, North Carolina. And she loves to go study sunken ships, looking at the microbiomes there. I think it's really kind of fascinating. Is this the ship that you're studying? Is it in danger? I mean, of being washed away, or hurricanes that come through there?
Absolutely. So these shipwrecks, they went down for a reason, and that environment is very tumultuous and is always changing. So it has been there since the 60s. So we know it has withstood some storms, but a lot of things are missing still from it, whether it's deteriorated over time. So that's why they don't have an exact identification on the wreck. It's one of the reasons. But yeah, absolutely. With stronger hurricanes coming through and storms, we could see issues with it long term.
North Carolina's Outer Banks, where this wreck is known as the graveyard of the Atlantic. So I imagine that you have a lot of ships that you could search for or do your research on.
Absolutely. So that is one advantage to being here in North Carolina. There are thousands of wrecks that have gone down off the coast of North Carolina, which is why it's gotten that name, the graveyard of the Atlantic. It is a very current heavy, constantly changing sediment environment. So it's really dangerous for these wrecks, the ships and the storms that come through, the really strong hurricanes. I've been through pretty much one a year since I moved here. And so that has always been interesting. I will also add a fun fact. When I started this project, and this is what we all do, okay, I'm studying microbes on shipwrecks. I'm so excited. I'm going to read what I can. And the first thing on my list to read was the book, The Graveyard of the Atlantic, about all the ships that went down in North Carolina. And so that was a really fun read.
Now, I understand Pappy's Lane is now like an artificial reef, right? Where reef, coral and things are growing among the wreck there?
Yeah, so it really is an artificial reef. So one of the fun things about going to the site to sample is you're snorkeling around, you're sampling. There are fish everywhere. In fact, sometimes they come up and nibble on you to see if you taste good while you're there. And I saw so many fish. There's oysters that have started to attach in areas, so we try to avoid that part, but there's a great source for them to attach and live. And so, yeah, it's become quite a ecological anchor and kind of hold spot for them.
So that's the natural evolution then, I would imagine, of a shipwreck. It becomes a wreck, it becomes maybe hazardous to navigation, it decays and then turns into an artificial reef.
Yeah, absolutely. And to me, that's one of the coolest things too about this wreck is, I think of it as a microbiologist that these ships go down and they have microbes already on them when they go down, but then they become a new home for all the microbes that live in the sediment, in the water. And then they start this whole new ecological niche and location for fish to come in and the oysters to come in. And it's just a wonderful thing.
All right. So tell me what you don't know and what you would like to find out.
About everything related to microbes on shipwrecks?
Yeah, about your research. Well, if I'll give you the blank check Science Friday question. If I had a blank check right here in my back pocket, I wish I did, and I could give it to you, how would you spend it? What kind of research, what kind of technology would you need?
Yeah, I really like that question. There's always good. So I honestly, some of the big questions I have are how different or similar are the microbiomes between these wrecks all over? We really have just scratched the surface on that. So if we want to design better strategies for preservation, we really need to understand that more. I also really want to look at, can we identify the microbes that are, kind of early indicators for issues for potential deterioration. So I really would like to design some sort of method that can help us with early detection. Just like with us, if we get sick, early detection is key. I think the shipwrecks are exactly the same way.
Dr. Field, we have run out of time. What I usually say, unfortunately, I want to thank you for taking time to be with us today.
Thank you for having me. I had a really great time talking to everybody.
It was great. Dr. Erin Field, Assistant Professor of Biology, East Carolina University in Greenville, North Carolina. And I want to thank all of you out there on our live Zoom audience. If you would like to join a future live SciFri Zoom recording, this is how you do it. Join in at sciencefriday.com/live stream. One last thing before we go. If you are looking for our book club conversation for this week, you can find it on our podcast feed or visit our website for live stream options. And as always, we'll put everything you need at sciencefriday.com/book club. You can always go right there. Charles Berquist is our director. Our producers are Alexa Lim, Christy Taylor, Katie Feather, and Kathleen Davis. And if you missed any part of this program, or you'd like to hear it again, subscribe to our podcasts, or you can ask your smart speakers to play Science Friday. I'm Ira Flato. We'll see you